So 3.2 is titled Trig Identities, but it's basically the same thing we were doing yesterday with one very small change. So a trig identity is just something that's true under any circumstance. So yesterday, what I wrote on the board 13 times, and what a minute ago you wrote on your quiz 13 times, those were 13 trig identities. It's always true that sine dividing cosine makes tangent. That's just true. That's a trig truth. There are other trig truths that we don't know. There's some that we will know. There's some that you'll never know. But a trig identity is any kind of those things that's true under any circumstance. Like 1 over sine makes cosecant. That's always true. The reason to learn these, as I said yesterday, is sometimes this is good for simplification. Sometimes this is good for equation solving. What you were doing yesterday was basically verifying that what they were asking you to do could be done. And maybe you were good at that, maybe you aren't good at that yet. That's a work in progress. But that's what we continue to do today. Today they're going to tell you something that is indeed true. They're not going to give you any that are a lie. Okay? They'll give you a bunch of things that are trig relationships that are true, and they're just going to ask you to show why they're true. So to show why these are true, what you're going to do is pick either of the sides and have to turn it into the other side. Most of the homework, you're going to work from the left side and turn it into the right side. But you don't have to. If you look at the right side and have a good idea and you want to turn it into the left side, that's fine. But what you would do if you're looking at a homework problem that looks like this is pick one of the sides where you feel like you have an idea maybe. And I said yesterday, what would I do first? Algebra ideas or trig ideas? Algebra ideas. Just like you learn algebra before you learn trig because it's easier. If you see an algebra sort of structure, I would look to attack an algebra structure before worrying about trig. So on the left, do you feel like you have an algebra idea? On the right, do you feel like you have an algebra idea? Neither one? What do you think?
Left side.
Left side. What algebra thing could you do to the left side? You could FOIL that. So if this is my homework paper, I don't write this down yet. That's what I'm going to try to produce like magic. It's going to happen. But I would copy down the left side, and then I would use my foiling idea. So if we FOIL this, we'd get a 1. What else would we get? There would be a positive cosine, a negative cosine, negative cosine squared. That's good foiling. Then I'd look at that, and I'd continue to think, can I do any kind of algebra with this? And at some point, we'll run out of algebra. Is there any more algebra that could be done to make that better? Combine like terms. Because what's going to happen to these when we combine like terms? They'll just eliminate. So we go 1 minus cosine squared x. We're just combining like terms. You might call that canceling. I understand that word. I won't criticize you over that. Technically, canceling is just when you're multiplying, but if you use that word, I know what you mean. Eliminate was probably a better word to use there. And then we look at this, and I'd say at that point, we've run out of algebra ideas. So we have to resort to trig ideas. The you being absent weren't here for what the trig ideas were. So we have a bunch of like things that we can trade for other things, but just by quick review from yesterday, one of our properties yesterday was that sine dividing cosine makes tan. That's one of the 13 things they memorized yesterday. So if we were looking at this problem and it had sine dividing cosine, I just replace it with tan. That's legal. Okay. There's some just trades we're allowed to make because of 13 items we learned yesterday. Somebody who was here yesterday, which of the 3 categories do you feel like we're using here? Pythagorean. What gives away that it's the Pythagorean group? The squares. If somebody has their paper from yesterday handy, maybe lend it to him just so he has it to like look at. If you don't need it, unless you keep peeking at it. If you've got to peek at it while we talk, then keep it. But there is a group of Pythagorean properties that all have squares in them. If you get the 1 reshuffled around, if you did enough algebra so you reshuffled it so it was 1 minus cosine squared. Well, let's do this first. Which way did you memorize it? What was it? Who squared, what's up with this thing? For the Pythagorean with cosine squared in it, that you just did a minute ago on the paper, what did you write?
Sine squared plus cosine squared equals 1.
Yeah, sine squared plus cosine squared equals 1. So if we algebra maneuver this so that we get a 1 minus cosine squared as a group, what is 1 minus cosine squared a fair trade for? Sine squared. That's the Pythagorean group. And when I originally wrote this up on the board, what we were trying to make this be equal to was sine squared. So at this point, we're done. We accomplished our mission. Hooray for us. Victory. Question about that? It's really no different from yesterday. That could have probably been a problem yesterday. The only difference is at the beginning, instead of saying turn this into that, they'll say this equals that. And you could pick either side. You could pick the left and turn it into the right, which you'll usually do, or you could pick the right and turn it into the left if you had to. Another technique that's not a bad idea at all on the longer ones is take the left and work it as far as you can. Give up. If you start then on the right and work as far as you can, you might achieve victory if you met in the middle. Like if you didn't know where she lived and you don't know where she lives, but you at least know she lives in that direction and you know she lives in this direction, and you just say, I'm going to just start walking toward you. I know where you are. You two might bump into each other around the power plant somewhere and be okay. You could meet in the middle. That can work on these. If you're working and get stuck, maybe start on the other side. Work back. Maybe you'll meet in the middle. It can happen. Question about that one? Okay, so here's a different one. Another just tidbit is you're better to start with the side that's just more complicated looking usually. But I'm going to say cotan x plus tan x equals cosecant x secant x. So first we've got to pick a side. If you have an algebra idea, pick that side. If you don't have an algebra idea, just use the left. If you're not sure, don't be paralyzed forever trying to pick a side. Just start with the left piece. So, do you have an overwhelming algebra reason to pick the right? Not really. So pick the left. We just want to make note in our mind that that's what we were trying to do. So now we need an idea. So cotan x plus tan x, I don't have an algebra idea. There's no like algebra there to do. It's just adding basic stuff. So we've got to do a trig idea this time first. Cotan's got a trade. Who can you trade cotan for?
Tan.
You could. Is there anything else we could trade cotan for?
Cosecant dividing secant.
Cosecant divided secant. Is there anything else you could trade cotan for?
Cosine dividing sine.
Cosine dividing sine. Those roads probably all could work. There's probably going to be an easier road to do. Does anybody have a choice out of those three which one you would choose to try first? I have a reason why I would try one of them first.
Cosine dividing secant.
We can try that and we'll see. That isn't what I would have tried first, but I maybe understand why you would do that because I was wondering about it. Why were you picking that one?
Because it has the two.
That's what you were making. Yeah, I don't know how that's going to pan out. Let's try it and see, because after we did it the other way, I was going to try it and see. I was more of a lean to cosine over sine. Why was I more of a lean, do you think, to cosine over sine, if you were anybody else leaning that way? They're the easiest ones. Sine and cosine are the easiest ones. Yesterday I put stars next to a few of them. Those are the ones I would always try to use first. But let's see. This could be cosecant over secant. This could be then, what's this one?
Secant over cosine.
Secant over cosecant. And that is from the quotient group. We are adding fractions. So adding fractions, what's our deal for adding fractions? Common denominator. What would you pick for a common denominator? Secant times cosecant. If you're going to change the bottoms, you have to change the tops. So cosecant times cosecant is cosecant squared. Secant times secant, secant squared. And I think we could save this, but I think it would be more work than it's going to be worth. What would you think next with the squares?
Cancel for
Now we can't cancel, if these are multiplying and these are multiplying, we could cancel. But if this is adding this, we're just kind of stuck with it. So it isn't going to be an algebra thing. I'm seeing squares, I'm thinking Pythagorean, but my issue is, there's one Pythagorean has cosecant squared in it, but it doesn't also have secant squared in it. And the one that has secant squared in it doesn't have cosecant squared in it. So I'd be trading one item for two, another item for two. I'd have 4 items on the top, and I feel like we're going in a direction where it's going to get worse. I was wondering if that would work, because I thought the same thing you did. These are the ones we wanted to make, that maybe that was going to be the way to go, but that didn't pan out. I wasn't sure. I most trust the properties with the stars. So when in doubt, I would always try those first. Our structure is fine, so I'm not going to erase this whole thing, but I'm going to do cosine over sine and sine over cosine. I would do the same common denominator. It's just the s's are sines and the c's are cosines. I'm thinking the same Pythagorean club because I'm still looking at squares, but why are we in a much better Pythagorean situation?
They're in the same one.
They're in the same one. Cosine squared plus sine squared makes 1. I could retread back to the beginning if we lost anybody with our change of direction. Did I lose you with the change of direction at the beginning at all? Okay. And then we're close to done. 1 over cosine might ring a bell from that paper. What was 1 over cosine? Secant. While we're at it, 1 over sine is also there. What's 1 over sine? Cosecant. And that's what we were trying to make. That was the reciprocal club there at the end. So that's another victory. So we're 2-0 so far today. Probably helps when I work with you. Little added bonus advantage. And I think I'd advertised that yesterday. It was going to get a lot harder when you got home. It's just, it seems easier when someone's there to like hit you through it. Anybody need time to absorb that? So let me go again. So I'm going to go sine over 1 plus cosine equaling 1 minus cosine over sine. Before we take that on, I'm going to do a small algebra rewind. So this is probably more of an Algebra 2 moment, so this may be like new to your life, but maybe you've had this because it seemed like you had a pretty thorough Algebra 1 life. So we've all seen stuff like this. So we're not allowed to have those roots on the bottom. Memory of how you fixed that situation in your past. Multiply by the root. So the top becomes 3 root 7. The bottom is just then 7. We're good at that. That's definite Algebra 1. That's familiar. Maybe Algebra 1, maybe Algebra 2. We dealt with stuff like this. and that became a slightly different project. We were still multiplying, but it was just a little different than what we were. Do you need anything, or are you all good? Got everything you need?
So I'm interested in math. You know.
There you go. We'll see if you know the answer to this question then. We also did that with, no, not feeling it. We also did some imaginary numbers in Algebra 2. So like you weren't allowed to have i's on the bottom. The way to fix that was like doing a multiplication. Does anybody remember what multiplications we were doing back in those algebra days? We had to get root 7 involved. And we had to get root 5 involved. Because what's happening is like a FOIL situation, okay, where the root 7s, when they hit each other, will make 7s. The root 5s will make 5s. The trouble is these are making root 35s. So if we don't want to create a bunch of root 35s, we don't want, how can we shield that from happening? With a subtract. Because now this and that are just going to eliminate each other out. Likewise, we used to do that here. We'd go 4 minus 3i. Foil that out, do some stuff. Vague memory of that? Yeah. You might have seen the Rudy version of that, maybe, or is that pretty unfamiliar? Okay. Key thing is just multiply by almost the same thing as its twin, just change the sign. Now here's the fun thing. Does anybody remember the name of that? If you don't, we'll play Hangman. When we turn this into this, it has a name. This is called the blank of that. That we used to have on the Algebra 2 quiz an occasional question where I'd say, find the blah 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 of this. And you just write that, you collected like a really easy point, moved on with your life, you were so happy about it, but then you forgot it. It's the same word that we used when we got into this stuff, when you were doing that, if you remember those. We put the little hats on the Z's, you remember that? That was this word as well. Memories? Oh, Hangman time. You get to pick the first letter. A is a good choice. You get to go again. Yeah, no, you hit. Yeah, you go. You know. So if you don't want to play, you need to pick like a Q.
C.
C, you hit. Like you were born to do this. T.
Oh my gosh.
Wheel of Fortune. Here you come.
B.
Oh, sorry. Or maybe congratulations, depending on whether you wanted to do that.
E.
E is a win.
S.
She was rooting for you hard. She didn't want to take a turn.
I.
There is not an I.
R.
There is not an R. I'm going to hang somebody. I can feel it.
O.
O is a win.
N.
N is a win.
What is that? F. Where's the S? Conjugate.
It wasn't your turn, so you don't get credit for the win. Yeah. That's called the conjugate. So the conjugate is back.
Sorry.
That's all right. You got excited. It's sped the game up.
Hey, I did remember FOIL first out
Yeah,
in
all right.
class.
There you go. That's good. Remembered something. So that's what I would suggest. If you ever see a single, this would be worth writing down in the notes. If you have a single fraction and there's adding or subtracting on the bottom, think conjugate. So a problem like this, I see a fraction, I've got adding on the bottom, I'm going to go with this side, I'm going to go conjugate. I'm not going to do that to this side because it's not adding or subtracting on the bottom. I'm maybe not going to attack that one. I'm going to just see if I can make that happen. So start from this side. I'm going to go 1 minus cosine x. If you feel OCD, like you want to give me like a reason every time, you could write conjugate, but in this setting, I definitely know a conjugate when I see one. That's not really adding to my life. I'm good. These are all invisibly in parentheses. So let's FOIL out the bottom. What do you think? think down there?
1 minus cosine squared.
Where'd the other stuff go? Like eliminated. So we would have had a positive cosine, we would have had a negative cosine. If you wanted to write those, you could, then you'd end up eliminating them. But we would settle on that. Let me continue to just work on the bottom. We could do the top now, we could do the top later, but maybe we're building up momentum on the bottom. All we did here was FOIL. Anybody have an idea to just continue working on the bottom?
Just be sine squared.
It would just be sine squared. Why is that? Because of the Pythagorean. So then the question would be on top, whether it's to our advantage to distribute, because that might have been what you wanted to do a second ago. If I said, what do you want to do to the top? You might have said distribute. But if we're going to end up with sine squared on the bottom, we're actually better off not to distribute it. Because if I leave this out there and don't mess with the parentheses, and this is still just hanging out there, and I haven't messed with the parentheses, what can these do?
Talking about the bottom ones, it would make the bottom just sines.
Yeah. They can cancel. I can cancel those. If this had sine squared, and this only had a single sign, and I cancel them, there's one of those two extra signs on the bottom. The top is that. Another reason why I might have thought not to distribute that is, and maybe I should have left it at the beginning. When I originally wrote the problem, this equaled another thing, and what it equaled was this. And so having 1 minus cosine on the top was the whole goal the whole time. And so at this phase where you've got a 1 minus cosine on the top, you've already largely obtained victory over the top. Don't mess up your victory by distributing and cluttering stuff up. Just kind of let that go. But we wanted to make this into that. Question about that? That's all that I usually do today, other than one other small algebra lesson reminder that does not affect your homework until like the 3rd day of this. I think we do 3 days of homework from the book on this. On day 3, we need this. We don't, maybe we need this too. I'll build up momentum with this. We're in algebra, we see that. What do you think about that in algebra days gone by?
Are you asking what it should equal? Or like
Hey, what can you do with that?
Like the ordered pair? Is that what you're talking about?
Like that? Is that what you mean?
Yeah.
Okay, that's what I mean to do. Anybody remember how to do that or what it's called?
And then like x, in first parentheses it's x minus 2, and then in the second one it's also x minus 3.
It's really close.
Oh wait, no, it's adding, so like,
It's,
so they're both pluses.
that's correct. So we go like x and x. X squared had to come from x and x. If this is a plus, we want to go same as each other, as well as being same as what this one has. So it's all about the pluses. And then we multiply to 6, but we add to 5. So 3 and 2 is a win on that. What was that called? It's an F word. It's not foiling or profanity. Don't make me play hangman again. F-A.
Factoring?
Factoring is correct. There we go. See, I can get answers now. I just have to threaten you with hangman, and then I get answers flow freely. If I change that to a minus, how would it change your factor?
They're both minus.
They're both minuses. If I change this to a minus, we're totally just back to scratch. It isn't even 3 and 2 anymore. If this is a minus, what happens to these? They're different. And then we're no longer adding to make 5, we're now subtracting to make 5. So who's the number pair that can work that?
1 and 6.
1 and 6. What does this do? Is it 1 versus 6, or 1 versus 6.
One's the first.
1's the first. That minus this sign, first sign, hogs up the bigger number. I don't think any of that's going to affect your trig. I do all of that just to get you back in a factoring mindset. I'm pretty sure something like this appears. This was called a difference of squares. That was easier to factor a difference of squares than almost anything else that we factored. Now I set you up for failure by saying it was easy. Sorry, I shouldn't have done that, I guess. Recollection of how that one goes? It's just x plus 3, x minus 3. So we had success, you came through. That was easier than the other system. You remember that, okay? That's like an Algebra 1 and Algebra 2 thing. We've done that both years together. Here's something that you probably won't remember, and if you don't, that's okay. Factoring a cube has a different pattern. This we're fine with. We go power cut in half. You square root the number. You just do the signs to be different. It just sort of flows. Instead of a number, let me just do all letters. Does anybody have any memory of how we factored cubes?
Don't you do 2 of them first?
We do this first, and then there's a longer second frame. Any memory of how this flowed? It's close. That'll be x minus y. So this time we cut powers in half because it was a square. This we're going to divide the powers by 3 because they're cubes. I don't want to do these as 30s permanently, but if those were 30s, these would be 10s. We divide by 3 there. But I like the 3s better. Then we built this one from this one by like a pattern that we just memorized but may have faded because, did you have Algebra 2 in person or in COVID?
It was
You were in person. Okay. Some people had Algebra 2 year was the COVID year. Some people had to do Algebra 2 in COVID. Memories of how this one built at all? Okay. We go x times itself to go first, yes. We go x times y for the middle. What do you think it would finish with? Y times y to get a y squared. And then if you're doing a negative times a negative, that's always a positive. This sign by memory pattern, we always did opposite of this sign for the same reason as the conjugate. It just helps get those eliminations just happen naturally. But we go divide 3, copy, divide 3, and then we build from here. X times itself, a new sign, them multiplied with each other, and then plus, and then the y times itself. I'm positive when we get into the third day of homework on this section, there's some cubes that you're going to have to factor. It's coming, but you don't need that for a couple of days. Let's look at some homework page stuff. I might have time to do like one with you guys if you have one that's really making you mad. The newest page is 77. So what we're going to work with on 77, tonight's going to go 1 to 12. Then there's a next day, middle day of this that'll work from 13 to 24. There's a third day of this that'll work from 25 to the end. So the next 3 days, there's no new information flowing from me. You're just showing up and saying, I can't do number 10, and then I do number 10. When you have one that you can't do, skip it. But probably go to the next one that doesn't look like it. So if you're looking at 77 and you can't do number 1, 2, 3, 4 look all about the same, right? So if 1 is making you mad, don't sit there and stare at 1, 2, 3, 4 because you're just going to get pretty upset, okay? But maybe 5 you've got a chance. If you can't do 5, don't do 6. If you want to try 7, if you get 7, you're probably going to get 8, right? Because those look about the same. They tend to come in little groups. So you kind of pick and choose where you want to go after this. And tomorrow's the day where if I end up doing one of each little mini group, so be it. That's what I'm here for. Whether you want to retry more the 1 to 24 or whether you want to more work on the 1 to 12 or you want to split the difference, I don't care. Tomorrow I'll just answer questions from whichever group. But with like 2-3 minutes left, did anybody have something from 75 that was like making you grouchy? You got to a point you're like, I need this one and it'll help you out. I can do one. Number 2. So 2, cosecant, you'd want to hopefully make 1 over sine. Does that make sense?
Yeah.
Tan make sine over cosine. And then see if canceling stuff can lead you somewhere good. Anybody else want a quick, the first four should be, first six actually should be based on make sines and cosines and then try to cancel. Anybody else that started the yesterday that got stuck somewhere?
So number 19.
19. So 19, I would guess it's going to be something Pythagorean with the top. Did you start that way at all?
Yeah, I did.
Yeah. That makes cotangent squared. Did you get that? Cotan squared on top?
Yeah.
Yep. Then here's a sneaky thing you could do. We didn't do anything quite like this trick yesterday, but you have cotan squared on top of cosine. You could write this as 1 cotan on top of a 1 if you like, another cotan on top of a 1 if you like, and then a cosine on the bottom that you'd have to write a 1 above it. Just kind of pulling it apart into pieces, like pulling a string. Cotan squared do 2 on the top, cosine do a single on the bottom. Do you understand that tear apart? Cotan is cosine over sine for one of them. I'm not going to attack the other one because I saw it was in the answer. There is a cotan in the answer for that one, so half victory from that. Attack these. What can you do with these? Cancel cosine. What's 1 over sine? Cosecant. And you wanted to have a cotan, which was our half victory, and we want a cosecant, and then that would be total victory. Did you follow that?
Yeah.
You got pretty far into that. That's good.